Chapter 3, Example 6. A class has been divided into groups of 5 students for an independent study project. At the end of the study period, they take an individual 20-point quiz. The scores by group are below. Find the mean score for each group and discuss their quiz scores. So we're going to calculate some means. We know how to do that already. You sum all of the data values together and divide by the number of data points you have. So in this case, we have 5 scores for each group. So for group 1, I'm going to do 10 plus 10 plus 10 plus 10 plus 10, divide by 5, which gives us a mean of 10. X bar is our symbol for a mean, and we do the subscript 1 to tell us it was group 1. So for group 2, I'm going to do X bar sub 2, and then I'm going to add 8, 10, 10, 10, and 12 divided by 5, and I get 10 again, the same mean. Okay, so even though I have different data points, the mean can come out the same. We'll continue for group 3. And once again, we get a mean of 10. Group 4. Again, a mean of 10. Group 5. Again, different data points, but the mean came out to be 10 as well. And finally, group 6. Once again, a whole different set of data points, and we have a mean of 10. So according to this, it looks like every group performed the same. Every group had a mean quiz score of 10, and thus seemed to have performed equally well on the test. Now there's all these spreads and scores based on the people in each group taking the test. So did they really perform equally well? Are we going to say that a group that everybody scored a 10 performed the same as like group 3 where somebody scored a 0 and somebody had a perfect score? So calculate the standard deviation for each group. What does this tell you about each group? Now, the standard deviation calculation can get a little complex, especially the larger data set you have. There's a lot of places that you can make a mistake. I do expect you to know how to calculate it by hand, because understanding what's going on in the formula will help you understand standard deviation, how it's the mean distance from the mean. There's some other little technical details that knowing the formula will help you with. Most of the time we will be able to use technology to calculate a standard deviation, however. Still, you need to be able to understand the formula and do these calculations if called upon. So the formula is sigma for standard deviation equals the square root of the sum of each data value minus the mean squared divided by the total number of data values minus 1. That's how you'll see it on the formula sheet you have for the AP exam in the textbook. But what does this really mean? So let's calculate the standard deviation for group 1. So sigma sub 1 equals the square root of the first point minus the mean squared, second point minus the mean squared, third minus the mean squared, and so on. So we do this for all 5 data points. Then we're going to divide by 5 minus 1. That comes out to be 0, because 10 minus 10 is 0, 10 minus 10 is 0, 10 minus 10 is 0. So each of those components on the numerator squared still equals 0. So we have 0 divided by 4. Okay, so for group 1, they all had the same score. There's no variation. There's no spread of it. There's no standard deviation. There's no difference between scores. That's what it's telling us. And that should make sense for group 1. Now group 2 does have some variation. You have a score of 8 and a score of 12, so they're not all 10. We'll do the same thing. Remember, we know our mean is 10 already. So sigma group 2 is 8 minus 10 squared, plus 10 minus 10 squared, plus 10 minus 10 squared, plus 10 minus 10 squared, plus the last one, 12 minus 10 squared, divided by 5 minus 1, which equals 1.41. So, on average, the scores in group 2 vary by 1.41 points. So the average distance from the mean for all the data points is 1.4 points. And that's all we have to do to calculate the standard deviation, but you can probably see how, with a larger data set, that gets very complex, very easy to make a mistake very quickly. Technology can do this more accurately and more quickly than we can in general. So for group 3, the standard deviation is 7.07 using the same calculation. For group 4, it's 7.21. For group 5, 9.06, quite a bit larger. And for group 6, it's 5.83, which is the third smallest standard deviation. The standard deviation tells us that group 1 was the most consistent, and group 5 has the greatest variation in scores. Maybe this means group 1 worked together, while a couple of people in group 5 did all the work, while the rest did nothing. We should not use the standard deviation for group 6 as the distribution is not symmetric. Now you want to look at the distributions first, clearly. I didn't show that on this example, but if you look, you have 3 scores below the mean of 10 and 2 above the mean, so it's going to be skewed a little bit to the left if we grabbed like a histogram. And those first 3 scores are within 2 points of each other, the last 2 are with 4, so definitely not symmetric. The others are purely symmetric. Group 3, 10 is my mean. I have 3 scores that are 10, and I have 2 scores that are exactly 10 points away, so it's perfectly symmetric. The same as with the other groups.